Hi class, welcome to this new video focusing on Laplace transform. In the previous video, we defined Laplace transform as an integral transform that converts a function of real time t to a function of complex number s. That is, Laplace transform of a function of real time t equals to convert a function of real time t to a function of complex variable s. You were also given in the previous video how to find the Laplace transform of a power function t power n, which equals to n factorial s n plus 1. In this video, together, we will see how to find the Laplace transform of an exponential function, of a cosine function, and of a sine function, sine at and cos at. Now, let's have a look on the first function, the exponential. So, Laplace transform of exponential at, as using the definition, if you can remember, we said that Laplace transform of a function f of t equals to the integral from 0 to infinity of f of t exponential minus st dt. Okay, applying this formula, call it 1 to this, we have that is equal to the integral of 0 to infinity of e at t times minus st dt, which is equal to integral from 0 to infinity of exponential minus s minus a t dt. So we can see from the borders of the integral that this is an improper integral. So to find the antiderivative of this, we have that it will be equal to the limit of k tending to infinity of minus 1 s minus a exponential minus sat k from 0 to k. And applying and finding this, what do we have? We have that is equals to the limit, right, when k tends to infinity of minus 1s minus a times minus s minus a k, right, minus 1 s minus a exponential 0. Okay, now let's have a look on how do we analyze this integral. So we have that this integral here, as you see, will be 0 if s is superior to a, and it will be infinity if s is less than a. That is, it will diverge, right? So therefore, to find a finite solution, so we will have that is equal to 0 plus 1 over s minus a for s superior to a. Therefore, we say that the Laplace transform of an exponential function equals to 1 minus sa for s superior to a. If s is less than a, it will diverge. Cool. Let's now have a look on the Laplace transform of cos at and the Laplace transform of sine at. Now, remember that exponential a theta equal to cos theta plus I sine theta. Therefore, if you have exponential at, it will be cos at plus I sine at. Now, we see that this is a real part and this is the imaginary part. So if we find the Laplace transform of this, right, Laplace transform of exponential I at, it will be Laplace transform of cos at plus I Laplace transform of sine at. We just apply the linearity property of the Laplace transform. So keep that in mind. So finding therefore the Laplace transform of this, we have that Laplace transform of IAT equals to integral from 0 to infinity of exponential IAT times minus ST dt, which is equal to integral of 0 to infinity of minus, right, SIT t SIA, right, t dt. Now we can see that this integral here is kind of similar to this one here. Therefore we applying the same procedure, we come to the conclusion that this integral is equals to 1 over SIA for S superior to IA, right? Okay, now we can't leave this answer this way because the complex number is in the denominator, so we have to conjugate this expression, which is equal to 1 over S minus A, S minus plus IA times S plus IA, which is equal to, yes, which is equals to S plus IA over S square plus A square, right? So this will give me S over S square plus A square plus I, right, times A over S square plus A square. So what do I see? I see that by inspection, this is a real part of this expression. It corresponds to cos AT, and this is an imaginary part of the expression. It corresponds to sine AT. Therefore, concluding, I will say that Laplace transform of cos AT equals to S over S square plus A square, and then Laplace transform of sine AT equals to A over S square plus S square. So, and all these, yes, over S square plus A square. Hi, so at the end of this video, we have shown you how to find the Laplace transform of an exponential function and the Laplace transform of a cos and sine function. You can also check this by using the Laplace transform table. Thank you very much. See you soon.